You know, the world's railways have been around for centuries, a real cornerstone of how we get around. But right now, they're caught in what you could call a perfect storm. They're getting hit by two massive crises at the same time, and it's forcing them to innovate and innovate fast. So let's dive in and see exactly how they're tackling this huge challenge.
Okay, so it all kicks off with a massive shock to the system. Just take a look at this chart. In 2022, the energy crisis sparked higher inflation in more countries than even the famous oil shocks back in the 70s. I mean, that's huge. The International Energy Agency even called it a crisis of unprecedented breadth and complexity. So we're not just talking about higher fuel prices, this was a full-on economic earthquake.
And for the railway industry, that earthquake created, well, a double challenge. They were getting hit from two different directions, all at the same time.
So on one hand, you've got the immediate price shock. I mean, the sudden sharp pain of just insane energy costs. But on the other hand, you have this huge long-term climate goal, that pressure to get to net zero emissions by 2050, based on all these global agreements. It's really the classic short-term survival versus long-term necessity problem.
So what do you do when you're caught in a bind like that? Well, the first response is pretty clever. You start working smarter, not just newer.
Railways are basically rolling out this whole toolkit of energy-saving tricks. You've got things like driver assist systems, which are like a coach in the cabin, giving real-time tips for more efficient driving. Then there are optimized timetables, which are all about syncing up trains so they're not all accelerating and braking at the same time. They're even just switching off engines when they don't need full power. And the best part? These are all things they can do right now to cut energy use and save money without having to do some massive, expensive overhaul.
And the impact of these measures? Honestly, it's pretty stunning. Get this. Swiss Federal Railways, SBB, they now recover a whopping 43% of the energy they use to power their long-distance trains, all thanks to something called regenerative braking. Just think about that for a second. That's almost half the energy it takes to get the train moving, being captured and reused every single time it slows down. That's amazing.
And this whole efficiency push goes way beyond just the trains. Some operators are actually turning their infrastructure into power plants. Take Infrabel in Belgium, for example. They've covered the roofing of a high-speed line with tons of solar panels, and they're not stopping there. By generating their own green energy, they're basically cutting the cord from the expensive and, let's face it, pretty volatile public grid.
But look, squeezing more out of every watt is great, but it can only get you so far, right? To really hit those massive 2050 climate goals, the railway industry has to do something way more radical. They have to completely reinvent the engine itself.
And that's where this word comes in, decarbonization. It's the ultimate goal. And this isn't just about being a little more efficient anymore. This is about getting rid of diesel completely. I mean, the European Green Deal is pretty clear. All transportation has to be firmly on the way to zero by 2050. And you can't do that without a massive fundamental shift in technology.
So, you might be thinking, wait, aren't a lot of trains already electric? And yeah, many main lines are. But there are still thousands of kilometers of track that don't have those overhead wires. So what do you do with those? Well, for those routes, two clear frontrunners have stepped up to replace diesel, battery trains, and hydrogen trains. And listen, this isn't some far-off sci-fi stuff. This technology is ready to go on a big scale right now.
And that sets up this really fascinating showdown, doesn't it? Battery versus hydrogen. Which one of these is going to power the railways of the future?
All right, so let's put you in the driver's seat. If you're in charge of a new train line with no overhead wires, what's your bet? Are you going with batteries or are you going with hydrogen? Let's break them down.
Okay, it turns out they have really different strengths. It's not a one-size-fits-all situation. Battery trains, they're perfect for shorter, more urban routes. Think up to about 150 kilometers. But hydrogen trains, they're the long-distance champions. They can go up to 1,000 kilometers, which makes them ideal for more remote lines. And of course, they need different stuff to run. Battery trains need charging stations, while hydrogen trains need their own special fueling stations.
So really, it's not a competition to see which one is better. It's all about picking the right tool for the right job. The European Investment Bank put it really simply. Hydrogen is great for long distances, and batteries are great for shorter ones. They're not rivals, they're actually two complementary pieces of the puzzle for a diesel-free future.
So this all sounds great, right? The technology is here, the strategy seems pretty clear. But of course, the track to a totally zero-carbon railway isn't perfectly smooth. There's still some bumps in the road.
Yeah, there are some pretty big hurdles to clear. First off, trains are built to last.
We're talking 30-plus years, which is amazing, but it also means replacing the entire fleet is a really, really slow process. Then you've got the cost. I mean, the price tag for all these new trains and the infrastructure to support them is just huge. And finally, you have to get everyone on the same page with standardization, so all these new technologies can actually work together without any chaos.
But here's the most important thing to remember. Despite all those challenges, the technology itself, it's not the barrier anymore. And this quote from the European Investment Bank really hits it home. For most trains, the solutions are ready to go. The industry can deliver.
So, this crazy twin crisis of cost and carbon has accidentally sparked a real revolution on the rails. The solutions exist, and the path forward is actually pretty clear. The technology's ready, so the real question, the one we're left with, is this: how fast can we actually build it?